What you're looking at is pumpkin toss. Engineering teams build massive trebuchets to launch pumpkins. There's over 20 teams, 150 participants, and over 3,000 spectators. The American Society of Mechanical Engineers at Utah State puts it on every year, and it's a great time. And yes, it is the same ASME as the ASME 14.5 standards. Alex and I met through ASME, and now that we're not running it, we decided to build one. So let's show you how to do it. This website's a great starting point to figure out how you want to build your trebuchet. You can change different lengths, weights, projectiles, and then from there you can test it and see what it would look like. It's super awesome, and then as you change things, we're going to see that you'll get a diagram that'll show you exactly what you can change and how that works. Then we went into SolidWorks and designed it, and here's the final design. It's a pretty simple trebuchet just because we didn't have a ton of time. But one thing going forward I would recommend if you're building out of wood or steel beams, use weldments. They're super nice to be able to just build easily. You draw a sketch, pick what type of material you want, and there it is. So now let's get to actually building it. Okay, well, let's see if our wood is going to come off of the roof.
No, it won't hit their staple.
Gotta get that shit.
Yeah, you gotta get our ingenuity here. Okay, you good?
For our build process, we started with the base and then started just working our way up. So this is just a little time lapse of finishing up the base and starting to work on the A-frames and a bunch of the other components. We didn't have a ton of time, and we knew there were going to be a lot of people helping us work on this. So we took the model from SolidWorks and made like some nice engineering drawings of those with lengths, angles, everything we needed. So we just gave those to people. They started cutting, and everything turned out great. It was super easy to assemble it after all the cuts were made.
Ryobi gets it done, baby. Ryobi gets it done.
Once we got all the major components assembled, we moved on to the arm. We got some big bearings off of Amazon so that we could reduce the friction of the arm swinging and take some torsion load off of the arm. But when we installed them, we found that the wood we bought from Home Depot wasn't parallel. Who could have guessed? To fix this, we printed some TPU gaskets that we put in between the wood and the bearings. So as we tightened down the bolts on the bearings, the TPU squished and made everything align super nicely. And after that, it started spinning great. Now that it was built, the only thing left to do was to actually go smash some pumpkins. So this is a video of the day of the event. ASME puts on a ton of different events that are super awesome, but my favorite has to be Pumpkin Toss. It's just a bunch of nerds building death machines and smashing pumpkins. So you can see out in the field there's a bunch of different targets, and we were right in front of the pool, so we thought we have to dunk a pumpkin. Like, it would be super sick just to see it splash, launch it out, get the crowd's reaction. We only had 2 test shots the day before, so we weren't sure exactly where we were going to be at, and we were going to have to make some adjustments on the fly. It's such a good time, and seeing all of the trebuchets launch is awesome. So thanks USU and thanks ASME for everything. Now let's get into some of our launches.
Team 11, go ahead and throw.
They are flying, will they hit something again? Almost, really good job. Team 11, go ahead and throw. They have a really great, oh wow! 12, Team 11, they are flying, oh! I think it's called.
Thanks for watching. Let us know in the comments if you want the plans for this trebuchet. We're also starting on our next open source project, so stay tuned for that. Thanks a lot, guys.
What are we trying to reduce, Zach?
Or